Hi, all, this is Mr. Yeager for chemistry. We are continuing our unit on the mole, and we're bringing in the molar mass now. So we've already done a couple conversions. We've already introduced the mole sum. We have already done the conversion between mole and liters. Okay, we practiced some of those. That 1 mole is always 22.4 liters. And we also did the last one here. 1 mole is 6.022 times 10 to the 23rd particles. So hopefully we have some good practice with those already. So now we get to molar mass. And so this one we are interested in converting between mole and how much that object actually weighs, its mass. This is going to be really the most useful one for us in our classroom, because we have electronic balances. We can measure out the mass, and based on that mass of that element or that compound, we can figure out how many moles are present. Okay? So this is another very powerful conversion factor. Once again, I want to just really emphasize all the conversion factors involve 1 mole and then the other number based on what you're using, mass, volume, or particles. All right? So molar mass. Molar mass, the definition is it's the mass per 1 mole. Okay? The mass of the element, the compound, per 1 mole of that. The units for it are grams per mole. You will be expected to be very good about your units in this unit. Okay, after you calculate out your answer. The units for molar mass are grams per 1 mole. So it's, again, always 1. And you can find these masses on the periodic table. All right? And I'm going to show you where in just a moment. So, for example, how can I figure out the molar mass of phosphorus? So what I do is I go to the periodic table and I find phosphorus, which is 15. That's the atomic number. It says the chemical symbol is P, it writes phosphorus, and then there's that number underneath of it that I've said we basically have ignored so far. In Unit 1, we called this the average atomic mass. All right? But we really didn't use it. We calculated it, but we never, if you remember, I said leave it alone. Do not ever touch that number during Unit 1. And we haven't talked about it since. We now are going to use that number, but we're going to call it molar mass now. It turns out the average atomic mass is the molar mass of the compound. So what I'm saying here is, and you'll see this pop up in a moment, is we're saying 1 mole of phosphorus is equal to 30.97 grams. All right? You'll see that we will round off the last digit on these using our periodic tables, the periodic tables that my class uses. We will round molar mass to the 100th place, okay? But this is what we're looking at. So we will write this out. I'll let this thing do it itself. 30.97 grams per mole. So you just look off the periodic table to figure out the molar mass of every single element. So you have all of them. You're not going to have to memorize them. You just have to find that decimal number on the periodic table. So oxygen, on your periodic table it says 15.999. Well, we're going to round that to 16.00, because again, we're going to round that last digit. Sodium is 22.990, so it's 22.99 grams per mole. All right, what about compounds? For compounds, this is what we do. Okay, we need to be able to count the atoms correctly. So what this is saying is this compound, sodium oxide, has 2 sodiums. So what we're going to be doing is I'm going to be multiplying the molar mass of sodium, which is 22.99, times 2. Because the idea is every single sodium oxide compound has 2 atoms of sodium. Each of those is 22.99 grams per mole, so I need to multiply that by 2. I then add that to the 1 oxygen, which is 16. Okay? And I would add those 2 together, and I get, there you go, 61.98 grams per mole. Okay? So we're just adding up all the different atoms that are in it. If there's more than 1 based on the subscript, you multiply that molar mass by that subscript. So PO3, we'd have 30.97. We don't need to multiply it by anything, plus 3 oxygen, so 3 times 16, and I add it all up, 78.97 grams per 1 mole. And the last one, Na3PO4. And again, I mean, you're going to have to do these. That's sodium phosphate. I'm going to have to multiply sodium by 3. Phosphorus will just need 1, and then 4 oxygens. So if I write it all the way out, you can see it right there, and the molar mass will be 163.94 grams. All right, per mole, sorry, grams per mole. All right, so you will be doing that. You'll be doing that on a quiz, you'll be doing that on a test, where I just want you to be able to show me you can find the molar mass, and you'll show me that work. All right, getting to the conversion part. So with the conversions, we have already done volume to mole and back. We have done mole to particles and back using their specific constant. Okay? Mass to mole, we're doing the same thing. All right? We're doing the same thing, but with this one, we do need to always calculate out the molar mass of the compound first. So, unlike the other two, the compound, the identity of the compound does matter. Okay? It does matter. We need to have the identity of the compound. For volume and particles, it doesn't matter. We're always going to have 22.4 and we're always going to have 6.02. But for mass, it does depend because we need to calculate out the molar mass and then either multiply or divide that. But we're going to follow the same method. Okay? So here we go. So I have 0.5 moles of AlCl3. So first thing, and I want to find mass. So this is saying we're going from moles to grams. But the second one we'll do too, moles to grams. Okay? So what I would have to do is I need to find the molar mass of AlCl3. So AlCl3, I'll write this all out this time, would be 3 times 26.98. Oh, no, that's already making a mistake. Sorry. It's just going to be 26.98. I don't multiply by 3. There's only one right there. 26.98 plus, I have 3 chlorines, so 3 times 35.45. All right? So if I do 26.98 plus 3 times 35.45, my molar mass is equal to 133.33 grams per mole. All right, now that I have that, now that's my conversion factor. This is my conversion factor. So, what did I say? How do we do these problems? I put in the number given to me with its unit, so 0.50 moles. I then draw my train track. Okay? I'm in moles. On the bottom is what I'm coming from. I'm coming from moles, going to grams. Moles is on the bottom, grams is on top. What you're coming from goes on the bottom, what you're going to goes on top. Mole is with another unit, so that's 1, always 1 mole. And we figured out it's 133.33 grams. Moles will cancel out. I can calculate 0.50 times 133.33. I get an answer of 66.665 grams. But I need to do sig figs. I don't ever use conversion factors, so we don't care about the sig figs of the molar mass. All right, just like we did with 22.4 and 6.022. We don't use conversion factors to figure out the sig figs. We're going to use the original number. And the original number has 2 sig figs to it. 1, 2. So my final answer has to have 2 sig figs to it. So the first 2 digits there. So it's going to be 60 and 7. All right. So there it is. Okay. All right, let's go to the next one. I have 0.25 moles of NaCl. I need to find the molar mass of it. So sodium is 22.99. There's only one right there, and I only need 1 chlorine. So I'm going to add those 2 up. 22.99 plus 35.45. I'm getting 58.44 grams per mole. Okay? So, I start off. I start with what's given to me. Always put in what you're starting with from the problem. 0.25 moles. I'm coming from moles, so that's on the bottom. What I'm going to goes on top. I'm going to grams. I only need, since it's always 1 mole in the conversion, and the grams is 58.44. I multiply those 2 out. Again, everything on top is multiplied. I get 14.61 I only have 2 sig figs, so I need to round it to 2 sig figs, so this becomes 15 grams. Moles cancels. All right. I'm going to do one more probably here. So 1.5 moles of MgCl2. So Mg, looking at my periodic table, is 24.305 plus 2 times 35.45. That's the molar mass of chlorine. Okay, 305, sorry. I'm going to reduce this. This should be rounded, like I said, to 3.1. Okay. 24.31 plus 2 times 35.45. Molar mass is 95.21 grams per mole. I start out with the number given to me, 1.50 moles. I put moles on, I'm coming from moles, which goes on the bottom, going 2 grams, which goes on top, 1 mole, 95.21 grams. Multiply that out. I get 142.815. I have 3 sig figs this time in my starting number. So I'm going to keep the first 3 digits. The 8 will round the 2 up. So 143 grams is my answer. All right, let's try going from the other way. Okay, what if I'm giving grams? All right, so if I'm giving grams, all right, I basically am doing the same thing. I still need to figure out that molar mass. All right, I know we found this one already, but I'll do it again. 26.98 plus 3 times 35.45. That equals 133.33 grams per mole. All right, so for this one, I'm going 0.875 grams. That means I'm trying to change from grams to moles. Since grams on top, I'm coming from grams going to moles. What number always goes in front of moles? 1. How many grams? 133.33. This is going to be a small number. 0.875 divide, and again, because it's on the bottom, we're dividing. Divided by 133.33. I am getting 0.0065626664. Well, how many sig figs do I want? I want 3. So this would be 0. I keep the placeholders. 0, 0. I'm looking at these 3. 1, 2, 3. The 2 does not round up to 6, so 656 moles. All right. Going again. Sorry, little announcement here.
This is the last call for students that are attending the Trade Talk field trip. Please report to the bus lanes. Thank you.
All right. So I add up the 2 molar masses of Na and Cl, 58.44 grams per mole. I have 1.04 grams. I'm coming from grams, going to moles. You can see I like to always write the unit before I put the number in, because people mess up where to put the number. 1 is always in front of the mole, okay? And we will only see that change when we get to stoichiometry. When a mole is with another unit that's not the mole, it's always 1. And then 58.44. So 1.04 divided by 58.44, I get 0.0177963. So I have 3 sig figs here. So I do 0.0, again, keep the placeholders, 1, 2, 3. 9 is next to the 7, so I'm going to round that up, 178 moles. And that's our answer. Okay? So, I mean, it's the same thing over and over again. You just got to make sure you know which way to put the grams and the moles. And that's all dependent on what you start with. What you're coming from goes on the bottom. What you're going to goes on top. Molar mass can be calculated by using the periodic table. Okay? All right. So, what we're going to do, that's the last of our single-step problems. We are now going to start doing 2-step conversions. And this is not anything additional or really special. It's just about staying organized. You are given the conversion factors, 6.02 and 22.4, and you can calculate molar mass. So we're just going to put all this together, and instead of having you calculate each thing one at a time, we're going to calculate it all at once using this dimensional analysis train track method. Okay? So, 2-step problems are going to occur when you are converting from something that's not moles to something else that's not moles. Okay? If you're going to the mole or you're starting from the mole, it's going to be a one-step problem. But if you're not in the moles and you're not going to moles, it's going to be two steps. So you can see all the different examples here. But the big thing here is you will always, always, always go through the mole to get to the next problem. There is no one step between mass and particles. Do not do it. Don't try it. It'll be marked off even if you somehow figure that part out. It's just not the right way to do it. You're messing around. You are using mole, but then you're just combining things for no reason. Okay? So take your time to go through it and take it step by step. Okay? So, examples are, and you have your chart. If I start with mass and I say I want to go to particles, well, there's no arrow here. You can go from mass to moles and then moles to particles. Not that difficult. Okay? In terms of those that always are like, I'm going to combine everything. Okay? You got to follow this method. All right? Especially because we're going to continue this method in stoichiometry where we get to three-step. And you need to show the process. The process is more important than the final answer. All right? In a lot of these things. So, that's what we're looking at here, is basically going, what am I starting with? If I'm starting with volume and I want to go to mole, well, that's just one step. Do one step and you're done. But if I'm in volume and I want to go to mass, I need to go to mole and then to mass. Okay? So, stay calm, stay patient. Okay? So, this one right here. Sorry, I'm going to change colors because I think black's going to be a little difficult to see. How many molecules are there in 125 liters of water vapor? All right. So, I do like to write this out for people as they're trying to figure this out. 125 liters. I don't like that. Let's try a different color. How about, will this one work well? 120, that looks a little better. 125 liters, and I'm going to molecules. It's good to write that out. And a lot of times the problems kind of already have it written that way, so you're like, oh, that's what I'm trying to go to. All right. So this means I need to change liters to, I can't go straight there. I need to change liters to moles, and then moles to molecules. So what I do is this, 125 liters, all right? I'm coming from liters, so that's on the bottom. I need to go to moles first, moles on top. What number is in front of moles when it's with another unit? 1. And we know 1 mole is 22.4 liters. That's off your chart. So you got that step done. Now, if that's all we wanted, we'd be done and we calculate. But we're going to keep this going. We're just going to add another track. All right, and I can cross out liters because it's on the top and the bottom. Now I'm in moles. So moles is what I'm coming from, and I'm going to molecules, which is particles. Moles is still 1. Molecules is 6.022 times 10 to the 23rd. You multiply anything on the top and divide by anything on the bottom. So, I mean, you could plug this in your calculator as 125 times 6.022 times 10 to the 23rd divided by 22.4 and hit enter. All right? So let's do that. Doing it right now. Stop telling me what to do. 125 times 6.022 times 10 to the 23rd times, oh, no, not times, divided by 22.4. And I get, I'll write out the whole number again, 3.360491071 times 10 to the 24th. All right? The thing is, I look at my original number, what you start with to figure out the sig figs, and I have 3 sig figs. So I'm going to keep the first 3 digits, and the 0's next to the 6, so it's not going to change. 3.36 times 10 to the 24th. Make sure you get that unit, molecules. That is that. All right? How about, we're going to skip that one. How about this one? Okay? This one's making you do all these volume to particles, but I'll do this one. I'm in particles. Okay? So I'm starting out with 5.75 times 10 to the 31st, atoms, and I want to go to liters. Well, I can't go straight to liters, so I'm going to go to moles and then to liters. So 5.75 times 10 to the 31st atoms. I'm coming from atoms, so it goes on the bottom, going to moles. 1 mole, 6.022 times 10 to the 23rd. Again, that's right off your chart. We know these things are equivalent. 1 mole is 6.022. That cancels out my atoms. If my problem was saying solve for moles, I'd be done. And I would just divide, but I'm not. I'm going from moles, now on the bottom, to liters. How many moles? 1, 22.4. All right. So I'm going to multiply 5.75 times 10 to the 31st times 22.4, and then divide it by 6.02 times 10 to the 23rd. Please, 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 as I always say, if you're dividing with scientific notation, put that in parentheses. Okay? I'm calculating it out. All right. Now, the thing is here, we should be in scientific notation, so be aware of that. What the? That's not what I want to do. Okay, well, I'll just do it this way. So, I get my number because I don't have my calculator set in scientific notation. It's 21388243111, which I should put this in scientific notation. 2.1388243111, 1, 2, 3, 4, 5, 6, 7, 8, 9, times 10 to the 9th. How many sig figs do I have? Well, if it's in scientific notation already, all of them are significant. So 1, 2, 3, move the 8's going to round the 3 up, so 2.14 times 10 to the 9th, and I'm in liters this time. Liters is my final answer. It's a lot of liters. All right, let's try a couple with mass. Let's just do different ones. So molecules, we're going to do one in here, and we'll do mass to volume. So it says, what is the mass? Let's just pick this one. What is the mass of 9.82 times 10 to the 24th particles? And I want to go to mass, grams. I can't go directly there. I'm going to the mole. Mole goes to grams. Okay? So I got to do 9.82 times 10 to the 24th particles. I'm going from particles to moles first. 1 mole, 6.022 times 10 to the 23rd. Then I'm going to go from moles to grams. This is molar mass. I know this is going to be 1, but I need to figure out the molar mass of sodium chloride. So I had to add up 20. There's only one. You need to know the formula for it. Obviously, it's NaCl. But I would just add up each of the molar masses. 22.99 plus 35.45. Is 58.44. I multiply the things on top. Divide by the things on the bottom. Put it in parentheses. I get 952.9737629. Again, you're going to see the habit here where we usually use 2 or 3 sig figs. It's 3 sig figs. I'm going to keep 952. 2 is going to round up because of the 9, so 953 grams. It's all about sitting there going, what am I in? What am I coming from goes on the bottom. What am I going to goes on top. And then just doing another step of it of I'm coming from moles, changing to grams now. All right? If I'm not solving for moles, it has to be 2 steps. So I'm going to find a volume, mass to volume. Let's do this one. I have 11.2 liters, and I'm going to grams of argon. Argon is not diatomic, so I just grab argon is 39.948, or 9.5 grams per mole, is the molar mass of argon right off the periodic table, and there's only 1 there. So 11.2 liters. I'm coming from liters, going to moles. Always a 1 in front of moles, 22.4 for liters. Liters cancels out, moles on the bottom, grams on top. 1 mole, 39.95 grams. 11.2 times 39.95 divided by 22.4. I get 19.975. 3 sig figs again, so 1, 2, 3. The 7 rounds up, which makes that one round up, so this is going to be 20.0 grams. All right, that's the process. Guess what you need to do to get good at it? Practice. So, obviously, work through some additional problems and work through what I give out. And obviously, if you're not in my class, work through what your teacher's giving out. Thank you very much.